Have you ever wondered how the nature surrounding you came to be? Over 4 billion years ago, Earth was a hot mass of molten rock, unsuitable for even the most resilient of life forms. As Earth began to cool, however, organic elements such as phosphorus, nitrogen, and carbon began to form, leading to the rise of the first organisms, namely prokaryotes such as archaea and bacteria. These organisms are known as pioneer species because they were the first to make the barren rock surrounding them their home. As they weathered the rock around them, died and decomposed over the course of millions of years, layers of dead organic matter combined with weathered rock into what eventually became soil. They formed the baseline of what would later become a lush, habitable environment for several other species, a process known as primary succession. Once an ecosystem has been established, a major disturbance, such as a natural disaster or road construction, may destroy or disrupt the ecosystem. Species recolonize or return to the previously occupied environment in a process known as secondary succession. In the 18th century, glacial ice was present at Glacial Bay National Park that has since retreated. Leaving behind bare ground, this retreat has paved the way for primary succession to occur and is currently being observed by ecologists all around the world. In a case study by 4 scientists in Alaska, the researchers stated, Glacial Bay National Park and Preserve in southeastern Alaska provides a unique opportunity to study the primary successional development of newly created ecosystems. Usually, only secondary succession can be observed due to human activity disrupting the ecosystem. Glacier Bay is such a unique location because it provides researchers with a rare opportunity to observe primary succession and predict the future landscape of Glacier Bay. And so the question arises, how are different organisms affecting the formation of a habitable environment in Glacier Bay? To answer this question, we compiled data from several case studies, photographs, and from Glacier Bay itself. Ecologist Dr. William S. Cooper was part of a group of scientists who urged President Coolidge to set aside Glacier Bay as a national monument. He is also known as the father of Glacier Bay. In 1916, he put quadrats on different plots of land at Glacier Bay to study biodiversity, and collected data from these same plots for 25 years. Today, the study has successfully extended into its 100th year. According to Jeff Pietka, one of the rangers at Glacier Bay Park, ecological succession at Glacier Bay follows this pattern. A year into the presence of bare rock, lichens, mosses, and a few tufts of grass, as shown above, begin to grow. A decade or two later, wildflowers, grasses, and small deciduous shrubs begin to grow. Sitka alder and willow shrubs begin to sprout. The alder is a key species, aiding in soil development and supporting other plant life by fixing nitrogen into ammonia, a compound necessary for plant survival. At the 50-year mark, the first evergreen trees arrive and develop. By now, several animals such as sea otters, sea lions, mountain goats, and puffins have made Glacier Bay their home. These creatures are considered to be specialist species because they have adapted to living in the tundra biome and would not survive well in other biomes. Unlike generalist species, they cannot adapt quickly when the environment changes. Finally, over several centuries, the evergreen trees will develop into a mature forest of Sitka spruce and western hemlock trees. Organisms such as pioneer and keystone species have helped shape the landscape at Glacier Bay Park during primary succession. By developing the land and becoming interdependent on one another, several organisms have helped create ecosystems and shape the landscape at Glacier Bay Park. Pioneer and keystone species have especially aided in the formation of a more habitable environment, encouraging an increase in biodiversity. According to National Geographic, the plots of land farthest from the glacial retreat have shown the greatest variety of organisms thus far, and it is predicted that the biodiversity at Glacier Bay will continue to increase. Data collected from Glacier Bay can be used to predict the future of other areas following extreme events, and further our understanding of how Earth and numerous other biomes have developed over time. Researchers at Glacier Bay are also planning to focus on the ecological succession that is taking place underwater and compare it to their findings from land. The future of Glacier Bay Park is bright. Thank you.